Okay, we're going to do lesson 10.6. It's on secants, tangents, and angle measures. Again, secants and tangents are not trigonometry terms here. They are different kinds of lines, and we're going to find the measure of angles formed by lines intersecting on or inside a circle, and find the measures of angles formed by lines intersecting outside the circle. So yesterday we had tangent lines, which are lines that intersect the circle at one place. And so in this case, we have a line that's going to intersect a line that's going to intersect it in two places. So we actually have two secant lines here. Here's one, line K, and you can see that it intersects the circle in 2 points. And then we actually have a separate line, J, that intersects the circle in 2 points there. For intersections inside a circle, so you can see that our first example here, they do not intersect inside the circle, but in this case we have an intersection inside. We have angle 1 and angle 2 here. And so what happens is, let's just kind of focus on angle 2. Okay, angle 2 is right here, and it has a vertical angle on this side. And vertical angles we know are congruent. And so they also create these associated arcs, arc BC and arc AD here. And so the angle that is created with this intersection is related to these two arcs that are created. And again, this is angle 2 right here. And the rule is that angle 2 would be equal to 1/2 the measure of the sum of the intercepted arcs created by the angle 2 and its vertical angle. So we're going to use both of these arcs, arc AD and arc BC. And kind of a neat way of deciding whether two arcs and angles go together is if you can draw a line through the angles and the arcs, those are the ones that go through them. In turn, if I were trying to find angle 1, its arcs that are associated are AB and CD, and I could draw a line through those as well. We're going to try it out here on the next page. Okay, so I have in example A, I have RU, that is a secant segment because it intersects the circle in two places, and TS, which is the secant segment. Again, it intersects in two places, and they intersect each other at point V, creating 4 different angles. So we want to find the value of X, and you can see that if I drew a line through angle X, it would also go through arc RS and arc TU. So those are the arcs that I'm going to use to help me find the measure of angle X. So the measure of angle TVU, which is where X is equal to 1/2 the sum of the measures of the arcs that we also went through here, which is RS and TU. So I'm going to fill those values in. I've got X degrees and 1/2. RS was 84 and TU is 130. And then we'll solve. So I have X is 1/2 of 214, and half of 214 is 107 degrees. So that's the measure of X. Okay, for B, similar situation where we have an X that we want to solve for, and I have these two arcs, but you'll notice that X is not associated with those. If I drew a line through the arcs, the angle that it actually goes with is this angle right here, AEB. Well, altogether, since this is a line here, X and the measure of angle AEB adds up to 360. So, or sorry, 180 degrees. Which means that the measure of angle AEB would be 180 minus x. So that's what I'm going to use for my angle measure when I set this equation up. So again, it's the measure of angle, in this case AEB, is equal to 1/2 its intercepted arcs, which is 143 plus 75. Well, ABE was 180 minus x. Okay, so what I'm going to do here is I'm actually going to get rid of this 1/2 first by multiplying both sides by 2. And so on the left side, I would distribute 2 and get 360 minus 2x. And then what happens on the right side is that the 2 and 1/2 reduce each other, and we still have the 143 plus 75. So I get 360 minus 2x equals 143 and 75 is 218. I'm going to subtract 360. And that gives me negative 2x equals negative 142. And then we'll come back and divide by negative 2. And I get x equals 71. Okay, this is a little bit different example here for the last one, so we definitely are going to go ahead and do that as well. We want x, and you can see x is in this arc, and then if I draw a line through that arc, and I can see I can go right through that angle and 97, so I'm going to use these values along the way. And we know that the measure of the angle, so in this case we would have angle GLH, is equal to 1/2 the sum of the intercepted arcs. So our arcs that we went through were GH and JK. So I want to fill those in with values that I have. So the angle was 110. The measure of GH was X, and JK was 97. So just like I did in example B, I'm going to multiply both sides by 2 because that's the denominator in the fraction. I have 220 equals then x plus 97, and then we want to subtract 97. And x is going to equal 123 degrees. Okay, so again, when I have an intersection on the inside, the angle that's created is half the sum of the intercepted arcs. We actually have a very similar example for this one. This is a different kind of problem, but if you look, we do have we have a secant line here, and then this is a tangent line. If I were to pretend that these kept going, okay, I actually would have, if I were looking at angle 1 here, I would have vertical angles, which create arc AB here. And then on the other side, there's no arc. So the measure, if there's no arc there, the measure of that is 0. And so how I want to think about this is the same way that we did the other problems. The measure of the angle, so in this case, the measure of angle 1, would be 1/2 the measure of arc AB plus, I didn't have an arc, so it's just 0 there, which results in having the measure of angle 1 equals 1/2 the measure of arc AB. That's where they got it from, but it's really the same thing that we did in the last page. So again, I'm going to do the same thing here. We want the measure of angle PQR, so we want this angle. If I were to extend my sides, I see that I have an angle here, there's a vertical angle, and there's no arc here, so its measure is 0 degrees. And so how I could set this up is say that the measure of angle PR is equal to 1/2 the measure of arc PR plus the other one, which is 0 degrees, because it doesn't even exist really. So the measure of angle QPR is equal to 1/2. PR was 148, plus 0 is still 148, and so 1/2 of 148 is 74 degrees. So that's the measure of angle PQR. We'll do a similar thing over here. We have an angle, 64, so that's what we're going to have to work with. But we actually want DEF. So I'm going to extend my sides here. Kind of pretend that these are intersecting. Again, this would be my vertical angle, and I don't have an arc there, so that's 0 degrees. What I'm going to find is arc DF. So I'm going to start with that. So the first thing is find the measure of arc DF. And forgive me, I know there's some shadows here. So the measure of arc DF is equal to 1/2 the intercepted arcs. Which are hang on, I'm sorry. Let's back this up just a little bit. I'm going to take the measure of the angle. It's the angle, FDC. So this angle is 1/2 the measure of the arcs. And those are my arcs. I've got DF, and then I've got this one that's 0. So my angle was 64. And times, then it would be measure of arc DF. So I could solve for arc DF there by multiplying by 2. And so the measure of arc DF is equal to 128 degrees. Okay, that's this. I still want arc DEF. Well, all the way around a circle is 360, so the measure of arc DEF would have to be 360 minus the 128 that we already have, which is going to be 232 degrees. So the same kind of thing there, if we imagine that those secants or tangents were extended out there, causing us to have an arc that's 0 degrees. So the same concept. All right, so what happens if we have an intersection on the outside? So the secants or the tangents and secants, they intersect on the outside instead of the inside of the circle. We're just going to do the opposite thing. So instead of adding the intercepted arcs, we're going to subtract them. And you can see we have a few examples of what happens. This is an example of 2 secants that intersect on the outside. Here's an example of a secant and a tangent. Here's an example of 2 tangent lines. In either case, to find the measure of this angle, we're going to take 1/2 the difference of the arcs. So I'm going to take the bigger one minus the smaller one. We wouldn't want to go the other way because that would give us a negative value. And so if we take the larger minus the smaller, we'll always get a positive value. The same thing for these guys. We have, here's an arc and here's an arc. Here's one and here's one. So in example A, we want to find the measure of angle L. And I can see that this is just like this guy up here where we have 2 tangents. And so we're going to take 1/2 the difference of these 2. Well, it's really all one giant circle here. So the first thing we want to do is find the measure of arc HJK. Well, since the 2 together are a whole circle and add up to 360, HJK would be 360 minus 102 degrees. So the measure of arc HJK would be 258 degrees. Now I can find the measure of angle L, because the measure of angle L is equal to 1/2 the difference of the arcs. So I'm going to take the bigger one minus the smaller one. So that's what it would look like. And then substitute any values that I have. So measure of angle L is 1/2, 258 minus 102. Which is 156. And so the measure of angle L is 78 degrees. All right, one more on this part, and I know I've kind of bumped into my space a little bit. We'll kind of mark that out. This time I want CD. I'm given actually the angle measure. The angle measure, angle A is 56 degrees, and then I have arc BC is 95. I can see that this isn't a complete, these two parts don't make a complete circle, so I can't subtract from 360. I'm just going to call this X degrees here. But I'm going to set it up the same way. I know that the measure of this angle is equal to 1/2 the difference of the arcs. So the measure of angle A is equal to 1/2 the difference of, see, arc CD minus the measure of arc BC. Well, A is 56. Arc CD is X. And BC is 95. Okay, you can recall in a few other problems here that we had to multiply by 2 to get rid of that 1/2, so we'll do that. And that's 112. These will reduce, is equal to X minus 95, and I'm going to add 95 to both sides, which would give me X is equal to 207 degrees. Okay, actually one more little problem, but it is super easy. It's just a word problem example, and it says the diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at a point A, B, and C. So it says that AC is 128 degrees. XBY is 84 degrees. We want to find D. So this is a very basic problem where we want to find the measure of the angle. The intersection is on the outside of the circle. So we're going to take 1/2 the difference of the arcs. So I'm going to take 128 minus 84.